Hello, in this video I will discuss using Kubernetes to provide high availability for our database containers. From now on we will call the containers pods because they'll be running in a pod. If you're not sure what that means yet, please pause this video and go back and watch the Kubernetes in 100 seconds introduction that is found in the preparation post. It's a very good video. It will help you understand the terminology as we go forward. Kubernetes will act as an orchestrator of our database pods and allow them to be able to recover in the case that they have been shut down or ended or terminated without our intending to shut them down. For this to work in the database environment, we have to declare the application as stateful, which means it has a persistent volume or storage or disk that lives on even after the pod of containers is shut down. This way, the data will still remain there if a new pod is created in place of the old pod. I will go through some of the information here regarding the configuration in a moment, but we'll start out by creating a Google Kubernetes Engine cluster inside of GCP. Make sure you're logged in as your BYUI account. Navigate to Kubernetes Engine, and then we'll create a new cluster. When you choose to create a cluster, you'll be presented many different options and a small wizard that offers to guide you through. Let's just configure a standard cluster manually. I recommend you name this cluster cluster-CIT 326 your last name. You can leave the 1 at the end if you'd like, or remove it. Every cluster comes with a default pool of nodes. Again, refer back to the Kubernetes in 100 second video to understand what the nodes are. The nodes are servers that basically do the work for the cluster. Let's take a look at those nodes. Each node has a machine type associated with it. Once again, we should choose the smallest possibility that can run the databases. I think in this case we'll go with small to make sure we don't run into any memory issues. We definitely don't need a 100 gig drive. Let's see what the lowest drive allowed will be. Let's go with the standard disk. And let's make sure we don't have more than one node. Let's go back to the default pool and we'll select one node. Now, generally speaking, multiple nodes is recommended in Kubernetes. We'd like to have multiple nodes to be able to share and balance our load between the different worker nodes. But in this case, where we're focusing more on high availability, we're only going to need one node to be able to demonstrate what we'd like to demonstrate, with the database being able to recover from a shutdown. So I recommend one node as a cost savings approach for this activity. Let's go ahead and create. It might take some time for your cluster to create. I'm going to use the one that I had previously created. Once you see that it's ready to go, open a Cloud Shell terminal up in the corner. And inside of that Cloud Shell terminal, we will connect to our Kubernetes cluster. Kubernetes commands always start with a kubectl, similar to our Docker commands, which always start with the word Docker. Let's take a look and see which cluster we're currently connected to with the kubectl config current context command. If you're not yet connected to your Kubernetes cluster through the Cloud Shell, you'll need to run a gcloud container clusters get credentials command and then give the name of your new cluster. You can see that in your previous window where you've defined your new cluster. You'll also have to make sure you note the proper zone that you defined your cluster under. There it is. and the project associated with the cluster. So your project should be right here in your Cloud Shell. Once you run this, you should then be able to run your config current context again and see that you are connected to the appropriate cluster to run your kubectl commands. At this point, we will go back to our documentation and start creating the appropriate files that are needed to customize this cluster to run both a website and a database. We'll start with running this command. You'll want to change this command to include the password that you want to use for your database. I recommend using CIT 326 capital BYUI PW. This command should have created a customization.yaml file. And inside of that file, we'll have this information regarding the secret, which holds the password for our database inside of the cluster. At this point, we will go back to our documentation and add the necessary configuration files to be able to run pods for MySQL and the WordPress website. If you look through this, you might see something that you recognize. You can look through this later for more detail, but one thing you'll see is we have a container defined and an image. So this configuration file will pull this image and create a container and pods necessary to be able to run the MySQL container in a pod configuration with the following port as part of our cluster. You'll also see the image related to the WordPress website. To get both of these, we will need to run these commands, which will download the files. So we'll copy each of these commands. We should now see all three files. You see the customization file and the YAML file for both of the deployments, one for the MySQL database and one for the WordPress website. This command will add both of those configuration files to the original customization file. If that's done correctly, I should be able to cat to read the customization file. And now I should see I have a secret and I have both of my resources defined inside of that, the MySQL deployment and the WordPress deployment. At this point, we are ready to apply and deploy to our cluster. All of my resources have been created. I should now be able to see everything running. If I run a kubectl it pods, I can see that my containers are being created. You can also make sure that the secrets exist with a kubectl get secrets. Again, that's where my password for my database is stored, so the Kubernetes cluster can log into the database. There it is. You can also see that my persistent volume got created. I might even be able to see that up here. If I now go look at my storage, the persistent volumes were created. Again, that's the storage that allows the pod to access storage even after it dies and comes back as a new pod. I should see a secret here for my password. And here are my pods. So much of this that I can see down below from the command line, I can also see up above in the graphic interface. Let's see if our pods are ready to go. I'm going to hit up. They're both running. Let's take a look at the services. We can specify a specific service or look at all of them. Notice the MySQL database does not have an external IP. This is handled behind the scenes as part of the cluster. The connections all originate from inside the cluster. However, we can connect to our load balancer assigned to our WordPress database. This is where it gets interesting. We can go ahead and take a look at the website associated with this new cluster. So copy your external IP, paste it into your browser. You should see a configuration screen to set up a WordPress website. If we go back to the documentation, it tells us to be very careful and not to leave the WordPress installation in this state. If another user finds it, they can set up a website and serve malicious content. So we either need to delete and shut this down now, or go ahead and continue and set up a user and password associated with our website so that it's safe. We're going to continue. So we'll set up an English WordPress website. I will give it a title. Call it Fear Fighting Thoughts. I need a username, sure, and a password, which I'm going to copy to make sure that I don't lose it. It does ask for an email address. Let's go ahead and set up our WordPress website, which will be using our MySQL backend. Here we are. We have a brand new WordPress website. So it's called Fear Fighting Thoughts. I'm going to write my first blog post to prove that it works. We will call it Fear Fighting Intro. I'll just go get one of the quotes from Teams. The Shakespeare quote is always a good one to start with. Paste that in here and publish this post. Now to view it, I can click on this link, and here we have a brand new WordPress website, and here's my post that I just made. If you'd like to see that in the database, let's go connect and take a look. As mentioned, the database does not have an external IP address. So to connect to it, we have to run a temporary container that serves as a client. This should be the command. Make sure your password is correct, and make sure your WordPress, your name of your service is correct. WordPress-MySQL, that is correct. If you log in successfully, you should see a MySQL prompt. So from here, we can show our databases. see the WordPress database there. So let's use the WordPress database. We can show tables. And we can even run a query to take a look at the posts that I just created. So I can select post date, post name, post content from WP posts. And although it's not pretty, you can see my most recent post that I just made with the Shakespeare quote inside of the database. So what would happen if one of these pods was ended prematurely? Now we're going to get into the benefit, the high availability benefit provided by Kubernetes. Sometimes services, containers, servers, sometimes they die. So I'm going to quit out of this connection for a moment. We're going to, again, look at our services or look at our pods. Here we have the pod that's running our MySQL database. So you can see I can refresh this. It's working just fine. I'm going to show you a little bit about high availability. Let's say this pod dies. We're going to actually just delete it prematurely here with the command kubectl delete pod, and then give the name of the pod. As soon as I run this, the database will go down momentarily. I should be able to switch over to our blog, our WordPress blog, and refresh it and see that I temporarily cannot access the website. So I'll hit enter. I'll switch over, refresh. Here we have an error establishing a database connection. But then once again, there it is. Now what just happened behind the scenes here? Let's take a look at our pods again. I have a new pod, which is the containers running MySQL. The name is different. Can I prove that it's different? What if I do a kubectl scribe in the name of the pod? What if I do a kubectl scribe pod and then the name of the pod? If I scroll up, I can see when it started and the internal IP address. So this is a 1096.0.13. Created 70 seconds ago. So let's do that all again. Let's delete pod, new pod. Again, refresh. See that I can't connect to the database temporarily because there is no database. But then Kubernetes brings it back. Let's look at what we have again. I have another brand new pod that's only been live for 15 seconds. Let's describe that one. We should see that the IP address for the internal IP address is different. Notice that it incremented by 1. So it's actually a different pod, different container. It's only been alive for 35 seconds, and Kubernetes continues to bring it back. So this is what we mean by high availability. And if we had multiple nodes, we would also have a fault tolerance there. If one node was to go down, Kubernetes can bring a pod up on the second node as well. The database should always be active. And if we go continue to actually read from the database, we'll know that the data is still there. Of course, I can see that the data is still there from the website, but if we didn't believe it, we could go connect to the database again using the exact same information that we used before to connect to the database. If I scroll through my commands, there it is. So now I'm connected to the database again. Even though this is technically a brand new container, it's referencing the same persistent volume. So the data is still there. I should be able to use WordPress. And run my select statement again and see that even though this is a brand new container, brand new database, data is still there. So what's the proper way if you decide that you want to remove a pod permanently? You would use a kubectl scale command with the name of the resource that you'd like to scale down. Looks like that. That would reduce the number of pods and not allow them to come back. Thank you for watching this video on how to achieve high availability using Kubernetes in a database environment.